I'm recording, so. All right, so I am really glad to be in class today, though, because today's lesson is probably one of the more complicated ones we've done in this class. It's one of those things that once you get it, and then it makes perfect sense, but sometimes it takes a minute to get there. So I'm going to do my best to make sure I explain it in a way that makes sense. Let's see how this marker is. It's good. The erasing might not be. Uh-oh, that's going to be a problem. That is not good. Maybe it's the marker. Let me try another one. Okay. Right swell. Oh, no, it's not the marker. Maybe this cloth. Let me see if there's a better one. I'm going to get through like one round of stuff on the board, then we're not going to be able to read it anymore. This one is not going to be better, trust me. Oh, yuck. Okay, well, we'll do the best we can. Clean cloths. Maybe that's all we need is clean one. No, that was optimistic. Okay, well, we'll do our best. I will try to get my erasing muscles really working today. Okay, so we are in 11.7. This is going to be the final technique for derivatives that we do before this first exam. And if you haven't checked, you guys, I did put up a practice exam on MathLab. It's there now. The 11, I think I did 6 and 7. I pushed those out as well as the practice exam to be due on the 10th. So like a Thursday night. Reason being, on Wednesday, we're going to come into class, but it's just going to be for questions about the practice exam. So I want to make sure if you do have questions, you can ask them and then you can go back home and work on it. And also, it's just nice to be working on it up until the day the test opens. So that's all going to be a Thursday night. There is some homework due Sunday, stuff that we've, covered a little, we've had some time. Just make sure you're checking your due dates. Make sure you know what's due Sunday night and what's due not due till Thursday. But anyway, you guys, so we are in 11.7. So this technique is really helpful because it's going to really open up the kinds of functions that we can actually take the derivative of without having to use the definition. So this is called the chain rule. And let me give you an example of a function. And honestly, it looks pretty standard, but we actually don't know how to take the derivative of it yet. So let's say I've got x plus 5 to the 5th power. I want to take the derivative of this. So I say we don't know how. We totally could. You guys, we could put this in the definition. We could also just FOIL this out 5 times and then take the derivative. Absolutely, yeah, but that is not something we want to spend time doing when we do have a technique for this. So this kind of problem, we're going to start seeing it as a function within a function. So this is where it gets a little bit tricky. Do you remember anything about function composition? Maybe not, maybe so. Maybe this will bring it back for you. But what I'm going to do is I'm going to take this function f of x, I'm going to decompose it into two different functions. And then we'll talk about why I broke it up this way. Okay, so I'm going to say that, not squared, g of x equals x to the 5th. And h of x equals x plus 5. Let's talk about how these two functions, if we compose them together, would make this one. So do you remember anything about composing functions together? So for example, if I was looking for g of h of x, this is composition. What it means is you take the one here on the inside. Notice, think about function notation. This could say g of 2. I know what that means. G of x plus 10. We know how to use function notation. That's all that's happening here. But instead of putting in just a number, I'm going to put the whole function h of x into the function g. Let's see what happens. So g of h of x, let's go ahead and replace this h of x with what h of x actually is. So saying that you want to find g of h of x is the same thing as saying I want to find g of x plus 5. Well, how do I find g of x plus 5? Function notation, right? I go to my g function, and everywhere there's an x, I replace it with x plus 5. So here's what g looks like. The x, or let's think about it as the input, goes right here, and whatever that input is, gets raised to the 5th power. Our input is x plus 5. So guys, this and this are the same. You guys, because what I did, like I said, I took this and I broke it up. I decomposed it into two functions. What I like to see is I like to have what I call like an outside function and an inside function. Sometimes I just call it like, what's the big picture? What's the big picture function? And what did I put on the inside of that function? We're gonna have to be able to recognize both functions that make up the functions we deal with today. Sorry. So again, this is kind of like a review of function composition and decomposition. So back stuff we did in algebra, putting one function into another function. And guys, let me give you the chain rule, and I'll show you how we can take the derivative using the fact that this can be written as two functions composed together. So let's say you do have a function f of x, but you can write it as g of h of x, just like we did. So we found two functions that composed together, they made f. But I want to take the derivative of this. So what you do, it's actually, the rule itself is not too hard to grasp. So what you're going to do is you're going to take the derivative of g of h of x, or sorry, I'm getting confused. No, that's fine. So you're going to take the derivative of g. I don't know if I want to put h of x in here. I think I want to just do the derivative of g. That might be a little more confusing than I want it to be. Okay, guys, I'm going to take the derivative of the function g, the big picture function. So notice, like in this example, we have x to the 5th. I know how to take the derivative of that. I use some power rule, right? But then I can't just ignore the fact that I have another function sitting within that function. So what I do is after I take the big picture function's derivative, I also take the inside function's derivative and I just multiply them together. So we end up with two derivatives, you guys. It's called the chain rule because it's like, okay, so I'm going to take the derivative of the function, but then I'm going to tack on a link to that chain, I guess. You're going to link on the derivative of the inside. So we are going to, like, you can see why we have to be able to pick out the two functions, because I do have to take the derivative of both of them. So let's go back to this. I'm going to erase the decomp. You guys, our chain rule is going to mainly consist of functions that look a lot like this, You guys, we're gonna see some kind of power rule situation, and then there's gonna be something in here that I also have to consider. So, taking the derivative of this function, I am going to start by using the power rule. In your head, just kind of, you know, think about this in a different way for a minute. If this was just x to the 5th, you know how to take the derivative of that. The 5 comes in the front, right? Remember, if this was x to the 5th, you'd bring the 5 in front, but then that x would stay the same. There'd still be an x in the problem. There's still going to be this in the problem. And then what's power going to be here? It's going to be n minus 1. So can you see the power rule happening around this term? That's taking the derivative of g being the power function part of it. But I say, okay, so I treated that like it was just x to the 5th, but it's not just x to the 5th, it's x plus 5. So then after you do that, you have to consider the derivative of what's in there also, and that's what you link on to the end. Now, this one is pretty easy because the derivative here, you guys, the derivative of x is 1, and the derivative of 5 is just 0. So really, we're just multiplying a 1. But it's not always a 1. You guys, it's a 1 on this one. Notice it's not really changing our problem any. It's not always going to be a 1. This is just our first easy example. So on this one, I get 5 times x plus 5 to the 4th. So again, that one you can't really mess up because the derivative of the inside function was just 1. But what about this one? What if I've got f of x equals x squared plus 3x to the 7th? Okay, so first of all, you have to be able to see that we need the chain rule. If this was just like this, that would be no issue, right? You just do the power rule on each of these. But that whole thing is raised to the 7th. So I want you to look at this as x to the 7th. If this was just x to the 7th, what would I do? Well, I bring the 7 in front, and I leave the x there. Remember, we have more than just x, but we still leave it there. And then we take a power off the 7, so we get this. So yay, I did the power rule. I brought it down. I took 1 away. But that's when you have to think, this was not just x. This is more than that. So you go to what this is in the inside. And you have to multiply, so link it on, the derivative of this inside part. So what is that? So this x squared, the derivative of that is 2x. Plus the 3x, you guys, that's just going to be plus 3. So here's the power rule. Here's extra coming from what was here. Now, on one like this, notice I did use parentheses because the derivative of this was more than one term, so I do need parentheses there. As far as simplifying your answer, you will never be asked to multiply something out to the 6th power. What you're going to do is you're going to leave this as is, but notice this is just 2x plus 3. This is just a 7. You can distribute those. So let's do the 7 times 2x is 14x. And then 7 times 3, that'd be plus 21. And then we have that term raised to the 6th. I think one of the biggest things that happens here while people are doing this kind of problem is the power rule part. That makes a lot of sense. Usually we get the power in front, we get the power taken away. Make sure that when you are doing that power rule, this stays exactly the same. Think about it. If we had x to the 7th, and then you brought the 7 in front and put it to the 6th, notice x isn't changing. You're not changing x in any way. It's the same here. Remember, we're pretending that's just an x for a minute. So whatever's in here does come down exactly this way. What happens is that people will try to do the power rule around it, but also take the derivative of this at the same time. Don't worry, you will take the derivative of this, but it's just gonna be tacked onto the end.
Why wasn't the 7 applied to the x squared plus 3x6? And
So-
then it feels like it was reversed, like,
So if you wanted to apply this 7 in here, you would actually have to FOIL that out to the 6 first.
Okay.
So that's just, think about exponents before.
but it didn't come down in front, so how did, I see what you did where the 14x plus 21, I see how that was applied.
Yeah.
But where, shouldn't we carry it down then, or, I mean,
So
how are you
here's what I
resolving it?
did. So I took this 7, I multiplied it by these two terms.
Uh-huh,
Since this didn't have a power on it, I could just straight distribute.
okay,
So I just put these two together and they made this.
right.
So from here to here, notice there's no derivatives being taken.
Mhm.
It's just, I did this times this, so I could just simplify the problem. And then I just, brought that one
So
down.
you don't have to put the 7 into that problem?
so you don't have to put it in here because you can't. Like I said, you won't ever have to FOIL out something to the 6th power.
Mhm.
This will be accepted, to come down as is. But I couldn't bring the 7 to that because of that power.
Mhm.
So I brought it to this just because I could.
Okay, so I understand that, but then why wouldn't you put the 7 in front of this, saying, this is what we're gonna do, but we're not gonna FOIL it out? It feels
So-
like it's just taken away from the problem instead of
So-
resolved.
So I used it. So think about this. So if we had 7 times x times y,
Mhm.
do I need to have in my answer a 7x and a 7y?
Not if it's 7xy, right?
Right. So here's what I did. I just put the 7 on the y
Mhm.
because it only has to go in one place. Does that make sense?
Because.
So
you
if
end up
I
having-
had, so I did this and I got that. If I put the 7 here also, then I would have a 7 that I took care of here and another 7, and it would be really 49.
So when they combine, the 14 will resolve it on the other side.
Uh-huh.
Okay,
So anytime you have like multiple terms multiplied together, you really only have to,
it's been a while since
Apply
I
it to
had
one
algebra,
thing, yeah.
so trying to put some
Yeah.
of these things back together.
so yeah, just being careful because, if that's something that just, like your head wants to do that, just be really careful because if you did do that, you'd end up having a factor of 49 in there instead of 7.
Gotcha, makes sense.
Okay, so let's do another one. So on this one, let's put a coefficient in the front. Let's have 3 times x squared plus 5 to the 9th. So first of all, again, I want to make sure, can you recognize that that's pretty close. You guys make sure I don't go over. Can you recognize we have to use the chain rule here is the first good question. Well, you can see a power rule happening, but because this is not just x, I'm going to have that extra piece. So remember how we're going to start. You always start with what's happening on the outside around this term. So what's happening around it? If this was just 3x to the 9th, what would we do? Remember, this is a coefficient, so it would just come down. The 9 would come down in front. We would have an x here if this was just an x, but since it's not, we bring down that whole term untouched. And then we take 1 away from the power, we get 8.
And then just to clarify,
Uh-huh.
so we're using the chain rule because there's a power symbol? Well, I'm just trying to clarify the definition for
So
when it triggers.
if this was not here, we would
Yeah.
just do it straight.
Okay,
But because it is, like, we could get away with not using the chain rule if we did FOIL this out 9 times.
okay.
But it's,
So it's just like whenever there's more than you want to FOIL, it's more than
Yeah.
2, more than 3, more than.
yeah, so anytime you can see the power rule, like if we had 3x to the 9th, that wouldn't be chain rule because that's just power rule, right?
Mhm.
Anytime that you have something raised to a power that's more than just x
Okay.
is a good way to see it. So we're here, we're halfway done. Here, I'll just move the camera over a little bit. Okay. So we're halfway done here, guys. I took care of the big function, right? I brought the 9 down, I took 1 away, I got the 8. But then I do have to realize that this is not just x, so it's time to take the derivative of what that is. This one, the derivative of x squared is 2x. That plus 5 is just a constant, right? So it just goes away. So in this one, I only have a 2x to worry about. So let's simplify. So you guys, you can do the 3 times 9 here and get 27. We have that x squared plus 5 to the 8th. Obviously, I'm going to leave that term alone. But I have this 2x. So you look at this, say to yourself, would it be that much trouble to multiply the 27 times the 2x? That'd be pretty easy, right? So let's go ahead and do that. So 27 times 2x will be 54x. And then you have the x squared plus 5 to the 8th. So especially on one like this, it's very tempting from here to want to put that 54x and start distributing it in here, right? But you guys, just remember that 8 is what's holding you back from that. So we are going to do a lot of problems that look a lot alike, but it's just practice, you guys. It's practice, practice, practice on this stuff. So let's see, I got f of x. Let's throw a negative exponent in there. Let's say I got f of x equals x cubed plus 3x. Sorry. To the negative 3. So you might say to yourself, oh, you know, I could put that on the bottom and then be positive 3. That's not a hard FOIL. Don't even go there, guys. Definitely use the chain rule anytime. Sometimes I even use it on squares. So, I mean, if you don't have to FOIL, then don't FOIL, right? But we're here, and it's already written as a negative exponent. So you can see the power rule happening. Like, oh, this is just x to the negative 3. How do I deal with that? Well, I put the negative 3 out in the front. This is where my x term goes untouched. Remember, ours is just more than that, but I still don't touch it. Negative 3 minus 1 leaves my power here at negative 4. And then, now that I'm done with the outside function, I go to this one and say, okay, so I pretended that was an x, so I could do this, but it's more than just an x. So I need the chain rule. I need to tack on the derivative of this inside part. So the derivative of x cubed is 3x squared. The derivative of 3x is just 3. So this is what I get. And then again, because this is just to the first power here, there's no FOIL necessary, you could take this negative 3 and you could distribute it here. And then we would leave this part alone. So if I do distribute that negative 3, I'm looking at negative 9x squared minus 9. And then I have that x cubed plus 3x to the negative 4. So I could write it like this. If you wrote it like this first and then this at the end, you know, you can switch those around. It's not going to matter. One thing I'm not sure of is, I'm not sure if MATLAB likes you to leave this as a negative exponent or if it wants you to put it back down in the bottom. So I'm going to show you both ways. You guys figure out which one it likes. It might like both of them. I don't know. It might be lenient. So just because this is a negative 4 power, note that we could take this whole term and put it down in the bottom to the 4th power. So by this time, we're probably getting pretty good at these negative exponents. But this is another way to write it. So this is not to a negative exponent. It's just to the positive 1 power. So that's going to stay on top. But you could put this on the bottom as x cubed plus 3x to the 4th like this. Again, these are the same, just 2 different ways to write your answer. Just be careful if you do it, or if you have to do it like that, because this entire term is to a negative exponent. That's why the entire thing had to come down. So it looks like chain rule works on positive exponents. It works on negative exponents. So we haven't dealt with fraction exponents yet. Let's see if it works on that. All right, let's do this one. So this one's a little harder to see because we can't see something raised to a power like we have on the others. But remember, anytime you see a root, but you want to take a derivative, you're going to have to turn that thing into a power anyway. So let's rewrite it. Instead of having a root, we will turn it into the half power. So the whole thing is being rooted. So the whole thing, I'll raise it to the 1/2 power because I know these two are the same. So this is equivalent way of saying this. And now you can see it, right? You can see I've got something in here. It's raised to a power. I got to do the chain rule. So if this was just x to the 1/2, what would I do? I'd bring a 1/2 down in front. I would leave the x here as is. And then I would take 1 away, which would leave this at negative 1/2. But it's not just x, you guys, it's x squared plus 7. So I got to use the chain rule. Oh, this is so awful. I got to use the chain rule here. Let's find the derivative of what is in here and tack it on to the end. X squared is going to be 2x. The plus 7 goes away. So we're just here. So as far as how to write answers on this kind of problem, you can absolutely distribute this 1/2 to this 2x here. And honestly, that's pretty easy. What I'm going to end up with when I do 1/2 times 2x.
1x.
Yeah, just 1x, right? So cut it in half. So you can just put an x out in the front. You took care of those two things. And then you can have x squared plus 7 to the negative 1/2. What would it look like if you had to get rid of the negative exponent? Well, you'd have the x. Notice the x is not being taken to a negative exponent, so that would stay on top. You could have x squared plus 7 to the 1/2 down here, so an alternate way of writing it. I doubt it would want it, because we usually don't like roots in the bottom, but here's an even alternate way to write it, is to put it back as a square root. So there's multiple ways you can write your answer here. What I would do as you're working your homework, because I like all of these ways, I think they're all great. But what I would do was put it in like this. If it says something about it to you, you know, put it in one of these other ways and see if it likes it better. I don't really know how strict it is about inputs. I don't know what you guys have noticed while you're working problems, but there are always multiple ways to write your answer. You just got to figure out the one that it likes.
With MATLAB, do you pick the questions that it asks us for tests?
Mhm.
Okay, so
Yeah.
they'll be very, very similar to the ones that we work in class, not like here's the version.
No, they'll be pretty
Qualifies under the
similar.
same subject, but you haven't done it.
Yeah. Yeah, so I picked the homework questions, I picked the tests and quizzes and stuff. So hopefully, like what I assign for homework, I know sometimes they're a little bit different. I challenge you a little bit more on homework. But for the most part, I try to keep what I teach you, what you have to answer on your own, similar. What you're going to notice on the practice exam is that you're going to see problems that you did on the homework. which I think, well, of course, what's homework for? It's for practice, right? So you shouldn't see anything on your practice test that you haven't seen before on a homework. I mean, including this homework too,
Yeah.
even though you probably haven't looked at it yet. And then what's really nice is that your practice test looks just like your actual test. So
Just numbers swapped out, but format's the exact same.
exactly. So I don't do the thing where I'm like, study these 50 questions and I'll pick 15 of them to put on the test. Like, I think that's just a waste of time. I want you to study what I'm going to put on the test. So they're going to be like carbon copies of each other.
That's appreciated.
I have these like nightmares of nights before tests, you know, when I was in school, and just studying just everything because you didn't even know what was going to be on it. And so I'd study, and then I get to the test and like the one thing I didn't study for would be on there. And then everything I did study for would just not be anywhere to be found. So it's just frustrating. Okay, so let's do a couple more. So we're gonna see, just like the power rule, you know, every day since we learned the power rule, we've used it multiple times. We're gonna see ourselves using chain rule just the same, you guys, because there's tons of times when functions look like this, when they're really a function within another function. So the better, like the more you practice it, the more you're gonna understand it. But you will get a lot of practice, so. Let's see, let me think of another one. So we did the root. We did a negative, we did multiple positive exponents. We'll probably just do a couple more of those. I know it might be overkill, but we're gonna still do it anyway. So let's do f of x equals, I'm just gonna make this one like a doozy. Let's have a 3 on the outside. On the inside, I want x cubed plus x, or plus 2x squared plus 4x. Let's make it big on the inside because it can be anything in there, right? And let's take this to the 5th power. Okay, so can you see the big picture function here? Think about it. What if this was just 3x to the 5th? What would I do? Well, I would bring my 3 down because it is an exponent, or it's not. It is a coefficient. And you guys, that's something that I want to make sure you understand too, is this 3 doesn't, like, it's not explicitly attached to an x because of the parentheses there. But remember, it still is attached to all of these values. So it is a coefficient. Don't see it as a constant. So it does come down. The 5 also comes down in the front. This is where x goes, or whatever we have for x, and we take a power away. But of course, we're not done. We just took care of the power rule on the outside. Let's take care of the inside. So this is going to be 3 terms, so make sure it's in parentheses. We're going to have 3x squared plus 4x plus 4. So we need the whole derivative of that, and now it's here. So to simplify, we could call this 15. We could also distribute that 15 to every one of these 3 terms, because this is just to the first power, and we're just going to leave the 4th one alone. So let's do that distribution. So this is 15 times 3x squared. We get 45x squared. Plus 15 times 4, 60x plus 60. So you took care of your 15, you took care of this last term, and then just bring down the middle. as is. That never, ever, ever changes. So let's do one more. So that was a big one. Usually you don't see them with 3 terms in there, but it's not something we can't handle, for sure. Okay, last one. It's not going to be a super hard one, guys, but I want you to walk me through it. So you in person, you out in virtual land, whatever you want. I just want to be walked through it. I don't want to give you the steps. So I've got f of x equals 4 times, let's do 2x cubed plus 5x to the 8th. So I'm looking at 2 functions. Remember, that's my goal. What is my outside function or my big picture function that I want to deal with first? Right, I got to use the power rule because I can see a 4x to the 8th. That's easy to take care of. So let's bring the 8 down. Oh, what do I do with the 4 though? This 4.
Bring it down too.
Bring it down.
I bring it down also. Okay, so I bring the 8 down. What goes here?
Your middle.
Is right here. Exactly the same, right? What's the new power?
7.
So that looks good. I think I'm going to call it a day. Are we done?
No.
No.
Absolutely not, guys. What am I going to do next?
Change the middle section to the power rule.
Okay. So I'm going to take this middle section. I'm going to take the derivative of that using just normal power rule. So I get 6x squared plus 5. So I'm basically done. How far could I take this? You guys, I could multiply those together. Let's call that 32. I've got 6x squared plus 5. All right, you guys, so maybe my next step is to distribute the 32 to these terms right here. Does that seem like a good step?
No, because of the power.
Right, please do not do that. I know it is very tempting, especially as you keep working problems. It just, like your mind just kind of goes on autopilot, right, sometimes, and it looks like something you want to do. Do not do it. Not unless you want to take that to the 7th power, which I don't think we do. But guys, I can distribute it to the last term. I can do that, so let's do that. Oh, 32 times 6. 216. Okay, so you get 216x squared plus 32 times 5. 160? No. What's 32 times 5 anyway? It is 160? Awesome, look at me. Knowing numbers and stuff. So you can do that, but don't touch the one with the 7. All right, so that's as far as we can take that. So practice, 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 and then more practice. You guys, you have tons of practice on this on the homework. You're going to see it on the exam in multiple questions. I say multiple, or probably just one or
Ma'am.
but still. Practice, practice. The practice exam, it is a quiz grade, which is fine because you can work that thing until you get all the answers correct. There's an unlimited amount of attempts on that, just kind of like homework. No time limit. You guys, your exam will also not have a time limit. So
comprehensive at the end of the semester? Will they directly?
Professor?
Practice quizzes or the exams?
That's my goal, as long as everything stays the same, as long as they don't try to stipulate like, as long as we can take our finals online, which
Yeah.
I think is fine, as of right now, that's the plan.
Yeah.
So unless something changes, it's gonna be online, it's gonna be a math lab,
So the
Yeah.
function is our reviews.
yeah, absolutely, yeah. I mean, if I haven't tested you over it throughout the semester, you're not gonna see it on the final, that's just mean and cruel, so. All right, guys, so practice that. I was wrong, so I knew I was wrong about something.
Hmm.
This is not 216. I know, everybody believed me. I tell you, it's the arithmetic, guys. It's like use it or lose it. You know, you start doing stuff where you're not just using just real numbers all the time, and you forget how to deal with them.
Really do.
That makes a lot more sense. That's why I was so
And
surprised with the 160. I was like, that doesn't seem like 32 different. Anyway, guys, so there we go. Be careful with your arithmetic, everybody. Okay, so yeah, that's it, guys. Work on your stuff. I won't see you on Monday because, you know, Labor Day. But Wednesday. So Wednesday's gonna be, just make sure you know, it's optional day. It's, do you need help on the practice exam? If you do, come ask me. One thing I do want to make sure you guys are clear on, like, I'm not gonna work the whole practice exam. Like, you know, like Wednesday's not just gonna be me starting with number 1 and going down the list. I want you guys to, you know, have looked at it, have tried to work through it, and you come with specific questions.
So Friday is the exam?
Yeah, it'll open on Friday.
Oh.
But, so we're actually still gonna have class on Friday. We'll just be learning,
You'll do the exam on your own time.
yeah. Yeah, it will be an in-class. It'll just open. You'll have the weekend. And then on Friday, we will just be moving on,
Okay, cool.
which is kind of nice. I mean, we don't have to take a class
Yeah.
off for the exam. It's kind of cool. All right, guys. So I will possibly see you Wednesday. Come at me with good questions.
Thank you very much.